Initially it was only 2. Now I have other row, that is high dose, where I have 3 observation of 9 variable. 3 observation of 9 variable. Now I want to run t-test on that. So for that, the command is t.test, dot test. To which group I need to apply? The subset what I have given, high dose. High dose, sorry. It is t.test. I'll again copy. It will be very easy. It will be advisable that first you write your commands in notebook, then you copy paste that, because when you are typing directly now, there are chances of mismatch, so error will be there. So t.test in bracket high dose. Now here, to which variable I am focusing on. So for that, a dollar sign first, then the parameter name. Here it is TNF alpha, comma, the mu is equal to, because I am one sample test, I am comparing this high dose TNF alpha level with a fixed value, with the fixed value, that is 100. That's why comma is equal to 100. If I run that, it will be giving me statistics. So it has run one sample t-test, high dose alpha. The t value is minus 25.94. The degree of freedom is 2. The p value is 0.00148. Alternative. So here, all hypothesis was, it is different from that. So null hypothesis is, because p value is less than 0.05, I'm rejecting null hypothesis and accepting alternative hypothesis, and I can say that high dose will be having different TNF alpha as compared to normal. My research question was like that: is TNF alpha level in high dose is significantly different from normal or not? So results say it is different. It is different. Okay. So summary bracket high dose. So I have given high dose D small, so it will be error. So I need to have capital D. And if I enter that, so see, it is saying no object is found, because for having summary of this, I need to have another command that make another table of high dose, which is having 3 observation, 9 variable, then it will be giving you. I have not made a different table. I have just made a subset of first. So for subset summary, there is a different command. There is a different command. In summary, then hyphen, then subset, then high dose, like that. Again, I am saying this is a language. You need to tell R in its language. Then and then it can understand and giving you output. Otherwise, it won't be giving. It won't be giving. Okay. So I have a general database, a hypothetical database, so that I can apply every test on that. So interpretation test whether drug significantly different. Now for that, next question is, does drug A, that is low dose, reduces TNF compared to control or not? Control or not? So now I'm comparing this two groups. So first, my data is there where it is everything, because I have more than two groups in that. So first I need to make a subset of that. So for making subset, these are the two commands. I can run everything simultaneously also, but for demonstration I am making small commands. Okay. So first subset will be control, second subset. So you can look, when I enter, you can look at here, it will be generating that. So there is a control and there is a low dose also, okay, where 3 observation 9 variable. High dose already we have made one subset, low dose three observation. Okay, so now it is made. Now the question is does low dose reduces TNF alpha compared to control? So here, because both are two independent, so independent t test will be there. So applying for that, the command is t same t dot test, dot test, t dot test in bracket control, and which parameter, because that control has also I can say dose milligram per deciliter, sorry, milligram per kg, day 0 level, day 7, day 14, interleukin 6 also. So I'm comparing only TNF alpha. That's why dollar sign TNF alpha control dollar TNF alpha, comma, now I am comparing with low dose. So comma the second group, low dose dollar sign TNF alpha. Now, comma and mu is equal to, I'm not writing because I'm not comparing with fixed value. I'm comparing between these two. What is the mean difference, mean of low dose and mean of control group, and what is the comparison between that, and what is the t test between that. So I'm applying that. That's why writing this command, and if you enter that, it will be giving you this. So the t value is 17.95, p value is 6.7, e raised to means it is less than 0.005. So alternative hypothesis, true difference between mean is not equal to 0. 95% confidence interval it is also giving. Okay. What is the mean of x and what is the mean of y, that is also given. Okay. So it is why this is important is R is important, because when you are submitting to FDA regulators, the script you also need to submit to them. So when you give this data set and they run this script, they got same output. That's why language is preferred. Nowadays, till now, FDA, US FDA is accepting statistical analysis that is run in on SAS. Now many companies are shifting from SAS to R also. SAS is also like that. It is a language. It is a language because you are also giving script. You need to submit the scripts. So when you give data and you give script, so they also, if they have doubt, they run that. In menu-driven software, it is not possible. It is not possible. If you are doing Prism Primer, or if you are doing in SPSS, or if you are doing in Jamovi, it is very difficult because outcome will be there and you will be writing same thing. You will be writing that. Okay, that's why. Okay. So this type of thing, it will be done on, I can say R. R. Okay. So another, if I say one way ANOVA comparing TNF alpha among all three levels, so I need to first, because already I have made subgroups. I directly need to run this ANOVA model. So it runs ANOVA, but means all three different are different. But among that three, which are different one, so for that I need to have post hoc analysis. So that very simple command is the Turkish test for ANOVA model. If you are running that, it will be high dose control. What is the p value? Low control. What is the p value? That it will be giving. It will be giving. Very simple. But this you need to give a script or all script. And they write that because it is a language, you write in this manner, it will be giving in that manner only. Okay. So I say pharmacologist, because we are doing research, and also we need to remember this type of language is also, it is too difficult for us. That's why we resist ourselves to use of R, because this command, when I teach you on this day, you remember. After 1 month, if you want to run this, you forgot what command you need to give. That's why the famous softwares are SPSS, Prism, or nowadays a new are there. This is called as Gemovi. Gemovi. Why am this is freeware. On this Gemovi, background on in background R is running. Gemovi is built on based on R language. So when you run on Gemovi, you are running your data on R. So in background, you have that R script is also there. So if you want to give that to submit a script to some regulators or some research article editors, you can give. That's why it is Gemo is somewhat new, somewhat new. It is from last 4 years, it is booming. From last 4 years, it is booming. Okay, it is a simple, I can say, spreadsheet type of thing is there. So where this is by default. Here also, different modules are given. As and when you require, they have given that modules, available modules. You select install, it will be appearing here. So by default, when you install Gemovi, just write on Google Gemovi software, statistical software, depending on your operating system. It will be for Mac, for I can say Windows. It will be having a different installation file. You can directly install. Another advantage of this Gemovi is if you don't want to install, there is also web-based Gemovi. Web-based Gemovi. So rather than using your space of laptop or your storage, you can directly run on web base and collect the data and analysis. Okay. When you install this exploration, t-test, ANOVA, regression, and frequency, this will be there. The additional two I have installed packages. Otherwise, up to this you will be getting. Up to this you will be getting. So similar to that, it is like a Excel sheet where all these rows are considered as a number of animals or number of patient, and all columns are considered as a variables. All columns are considered as a variable. This also accept SPSS file, Excel file, text file. Okay. So your data, if you have in Excel, if you have in text file, you can directly or in CSV file. So here open, sorry, open, browse. So I have this Gemovi dataset. I have in CSV format. So by browsing, if I open that, it will be there, opening. As I've told you, it will be eating your memory. So I have this first variable animal ID, second variable groups where control standard, taste low and taste high is the dose. Okay. This is your, if you want to change the data type from continuous to nominal, you can just double click on this. So this will be a pop-up. So it is continuous, decimal is there or not. If you click on this, it will be going back. So like that, you will be having a data set. Okay. Now to run on this, how you can run on this. So I'll be opening that various so Gemovi dataset where I have used Vista Red, Carrageenan induced paw edema I have done. So paw volume in ml, blood glucose level, and survive or not. That outcome I have measured in this. Okay. Baseline paw volume, edema, 1 hour, 2 hour, 4 hour, blood glucose level, and survive, yes or no. Okay. So if it is no, 0, so I 1, like that. You cannot write yes and no because statistical software doesn't understand yes and no. You need to convert that into code. Okay. So that I have, and I have group control, standard drug, taste drug low dose, and taste drug high dose. So variables that is included, animal ID group. Okay, this already I have told you. So on this database, I can run this different test. I'll be running this. This is, I can say, text file of my data. So from that text, I have converted into CSV and I have installed. So first question, is baseline edema is different from normal value? Normal value means I have fixed value, 1 ml. So for that, what I need to do is go to Jamovi, go to analyze. Here there is a t-test, in that one sample t-test. The another advantage thing of Jamovi is when you click on this, simultaneously on right side, everything is calculating on before your eyes, it will be calculating. Now for that, what is the my question is, my question is baseline edema different from normal value. So when I click on that GEMOV t-test, one sample t-test, so it will be asking what is the dependent variable. So my question is baseline variable, baseline. So I have that baseline edema is different from one or not. So my dependent variable is this. So it is calculating. It is calculating, directly calculating. Okay, because by default t-test will be there. T-test will be there. Now I want what is the description. So if I click on that, what is the description? So total there are 20 observation. The mean is 1.20. 1.20. But what I'm doing is one sample t-test. So I need to have test value. Here hypothesis test value is 0. That's why it is showing me this. But my test value, I need to compare. My question is 1 ml. Is baseline edema different from normal value? My normal value is 1 ml. So I need to write here 1. Then click. So it will be calculating statistics. Again, I'm making it 0. Clicking. See, it is changing. Okay. Baseline edema. I need to compare with 10. Sorry, 1. If I make that into 10, it will be calculating according to that. If I am making that to 1, it will be calculating according to that. Okay. Now you want that uh, what is the mean difference between that you can have. Descriptive you can have. Descriptive plots you can have. Okay. But here, I told you that when you do parametric test, you need to check for normality test. So this normality test also, if p-value is greater than 0.05 means normally distributed. So it says that's why you can go for t-test and your assumption. Otherwise, if it is not there, you can just click on Wilcoxon test. So that Wilcoxon data is also there. So GEMOE, no need for parametric menu, different set of instruction, non-parametric different, because if you go for prism or if you go for SPSS, you need to run differently. But here simultaneously you can select both. So both result will be coming. Both result will be coming. Okay. Both result will be coming. Okay. Before that, yeah, so simultaneously graph will be also available. Otherwise, if you want then exploration, uh, this type of data is also available. So it is very easy. Again, I'm starting with GEMOV, same data set, just repeating so that you can know how to load the data. So I run one independent t-test, and I'm trying to show you that how much RAM it will be taking and how much time it will be taking, because I'm using some older laptop. It is taking time. Open, browse your previous GEMOI dataset CSV file. So now I want to I have a question. Is edema at 4 hour different between control and standard? So if same question I'm analyzing in R, what I'll be doing? First, I need to make subset and then I need to run. Here it is menu driven. It is menu driven. So it will be very easy. So here my dependent variable is edema at 4 hours and grouping variable is standard. So in this, I'm going for independent. So it is independent t-test. So independent t-test. So I need to have a dependent variable. My dependent variable is edema 4 hour. I need to just either picking that up and dragging here or selecting and clicking on this arrow, it will be coming. Grouping variable, I have already grouped variable. So group in grouping variable. So it is more than that. It is more than that. Okay. So grouping variable doesn't have because I have more than that. That's why it is showing that error. So for that, I need to check my data and I need to only have selection. So I need to have a command that only I'm deselecting this, I'm deselecting that, and then applying. Okay. Or otherwise, I can delete that and I can apply. I can apply like that. So, same data set, I can select, I can delete. So, what will happen that I have 10 groups, but I want to analyze only on between two group. So in R, what I am doing, I am making subset and then applying analysis. In this also background R is running. So I need to select and I need to then apply for selected data. For selected data. Okay. So if you are applying that, okay. These are simple tests. One way ANOVA, repeated measure ANOVA. Okay, fine. I'll demonstrate one way ANOVA compare between edema at 4 across all groups. Okay. So like that analysis ANOVA, one way ANOVA, dependent variable will be all edema 1, sorry, edema 4 hours edema, 4 hours and all groups. So it is saying ANOVA table, it is showing this, but I need to have my descriptive tables that control 5 mean is this, standard 5 number mean is this, standard deviation, standard error. I need to check for normality. Normality check is fine. So I can go for one way ANOVA. No issue. Equal variance. That is fine. Now, this ANOVA table is say, this ANOVA table says there is a difference between 3 group, but between which group it is having difference. So this is post hoc analysis. If I click on Turkish test, its outcome will be displayed here. So control with control hyphen, because control I cannot compare. So control with the standard. The difference is 1.36. The p-value is given here. So it is significantly different. So control is significantly different from standard test as high, test low. If I say this standard, same way. Okay. same way. So you can easily report this. Okay, homogeneity you can check, because ANOVA also say the homogeneity of variance should be also non-significant. So it is non-significant, then and then you can apply that. Otherwise, if it is violated, you need to have a post hoc analysis, different post hoc analysis. It is not like that. If a homogeneity is variance is violated, what I can do? I cannot apply ANOVA. You can apply ANOVA, but you need to treat that data in that manner, and you need to interpret in that manner. That is important. It is not like that you just stop at that site. Okay, this is descriptive plots. This is by default, a plot is given here. Otherwise, if you want, like prism, if you want to have a box plot, you can have a box plot here, like grouping variable, and at 4 hour, so it will be box whisker plot will be there. Control what is the value, like that. If you having want to have a bar plot, so between grouping variable, like that. So you can also have a plot, not an issue. Okay. So to same, if I want to have repeated measure on our, does edema reduce over the time within the group or not? So for that, I need to have within group sample, between group sample. This is somewhat tricky one. So analysis, repeated measure ANOVA, repeated measure ANOVA. So what I need to have? Repeated measure. So edema 1, 2, 3. Okay. So repeated measure this. Level 1. Sorry. First I need to have this. 1 hour. Sorry. 2 hour. And third is 4 hour. So it will be generated here. Now I need to drag the repeated measure in that 4 hour. In between group, so here in section, the between subject, I need to have groups. I need to have, sorry. So it says that between group, it is significant. Now, if I want to check post hoc analysis, that interaction is existing or not, I can run that also. Okay. And partial eta is also a very good thing. So partial eta or eta square. Okay. You can have Turkish test or you can have Ben Ferroni test. You can run that both. Okay. So like that, you can have a repeated measure ANOVA in JAMOV. You can also have relation between glucose and edema is there. So where you need to have correlation analysis. Yeah, correlation matrix. So it is menu driven. It is menu driven. Very easy. Very easy. Okay. So if you have any doubt in this, you can ask. So this is what two software are looking. From my side, I can say software are something like that. You need to play with it. If you play with it, it will be very easy. So this is from my side. If you have any question, you can ask. And hope I have justified. Oh,
Yes, sir. Thank you very much. Request to the participants to, if you have any questions, you can put them in chat box or you can speak directly. Sir is there to answer your queries.
Manoj,
Yes, sir.
we will also send the resource person email ID with their permission on the FDP group, so
Yeah,
that
yeah, sure, sure,
uh,
sure.
any
So,
person having any problem, they can contact you by email.
yeah, if you have your data set and you are confused between that, what I need to do with that, I'm happy to answer.
Yeah, yeah.
Not an issue.
Thank you, sir. Okay, Manoj, conclude.
Yeah. Sir is there with us. If he wants to say something on today, sir, please.
Yes, good afternoon.
Good afternoon, sir.
This was a good knowledge revising kind of presentation by Dr. Bhavin. I was also amazed looking after the slides. It was an excellent lecture. And thank you very much for your time. In spite of your holiday, you came to the college and delivered the lecture. This kind of teachers are required to build the teaching fraternity and make them serious about their affairs. Thank you. Thank you very much.
Thank you, sir. Thank you. It is always pleasure to present against you also, sir.
Yes, it is pleasure to listen to you too.
So thank you very much, sir, for such an informative, practical, and lucid session. The way you explain complex statistical concepts and their real-time application in the pharmacology research was truly beneficial for all of us, especially what you have started from the basics of biostat and dive deeper into the selection of the different statistical tests as per the data, the usefulness of the R Studio, as well as the GMOB. So on behalf of SNJB's Sriman Suresh Dada Jain College of Pharmacy, Chandwood, it is my honor to present the virtual certificate of appreciation to Dr. Bhavin Vyas as a token of our gratitude for sharing his valuable time, knowledge, and experience us with today. Sir, please accept our appreciation and gratitude for
Thank,
for the lecture. Thank you once again, sir, for
thank you,
accepting
thank you.
our invitation and contributing meaningfully to the success of this FDP-SDP. Thank you, sir.
Thank you very much. Thank you.
Before we conclude today's session, I request all the participants to kindly ensure that they have filled out the attendance list for the day second of this SDP-SDP. Tomorrow, day 3, we shall be exploring frontier areas in pharmacology with focus on future trends, and we look forward to your continued enthusiastic participation. With this, I conclude today's session. Thank you all for your valuable time and active involvement. Have a wonderful day ahead.
Thank you.
Thank you.
Okay. Thank you, Dr. Bhavin.
Thank you, sir.